So I will be taking up curvature next, huh? Now what is curvature? Okay. See, let me take two curves, PQ and P dash Q dash. You see these two curves are there. This is PQ, this is P dash Q dash. Two different curves. But let me suppose that arc length is same. S is the length. Its length is S. Arc length of P dash Q dash is also S. Now, one can see without using mathematics that this curve has more bend than this curve. This curve bends sharply than this curve. So we say this curve has more curvature than this curve, right? This can be seen. Anybody can say that this curve is more sharp, bends more sharply than this. But how to do it mathematically? How to define it mathematically? See, if at this point P, I will draw a tangent to the curve, and at point Q, I will draw another tangent. And let me suppose that these two tangents make an angle psi over here. Again, this is of same length S, this is also same length S. Let me draw a tangent on P dash and a tangent at Q dash. And let me suppose that this angle is psi dash. We can see that this angle psi is bigger in this case and this angle psi dash is smaller in this case, although both these curves are of same length. So we say that average curvature for this curve is psi by s, and for this curve it is psi dash by s. And we say obviously greater the psi, greater the psi, greater will be curvature, less the psi dash, less will be the curvature. So it depends on this angle psi. We say this curve bends sharply mathematically if psi is more, and for this we say it bends less than this because psi dash is less than psi. So average curvature for this curve is psi by s, and for this curve it is psi dash by s. Now what is curvature at a point? This was curvature of a curve. Curvature at a point. See, let me define it now. Let me take a curve PQ. Let me take a curve and let P and Q be 2 points on this curve. Let this be a curve, and let us suppose that P and Q are 2 points on this curve. Let A be a fixed point, and let me suppose that distance from A to P, it is S. Okay, I have to define what is curvature at point P. Okay, let this be the tangent to the curve, to this curve at P, making an angle psi with initial axis. Okay, fine. Let Q is neighborhood of P. Let us suppose that, see, let me again explain. I have taken a curve P, and P and Q are two different points on this curve. P is actually a point and Q is its neighborhood. Fine. And length of this curve is S. This is the neighborhood of the point. So this is very near to this point S. This Q is very near to point S. Now let me take another tangent on Q This angle will be bigger obviously, and this, let me suppose that this is psi plus delta psi, and this angle will be obviously delta psi, and this angle is also delta psi. Exterior angle, sum of interior opposite angles. So psi plus delta psi, this is psi and this is delta psi. Clear? Obviously greater than delta psi, greater will be the curvature, as I have defined here. Now, how to find curvature at a point? This is quite simple. Now, average curvature is delta psi by delta s. Now, curvature at point P. Let me, if Q approaches P, this is delta psi. This is the increment in s na, because this is A to P, this is s, and from this to this is increment. This will be delta psi. So, if I have to find curvature at this point P, let me suppose that Q approaches P. In that case, delta S will approach to psi. This is the average curvature. Now, curvature at point P is given by limit delta S approaches 0, delta psi by delta S, which is d psi by ds. This is curvature at point P. Delta S approach 0, this will be d psi by ds. So curvature is denoted by k or kappa d by c. So this is curvature at the point P. At the point P, when Q is approaching to P, delta S approaches 0, this is denoted by. And radius of curvature is the reciprocal of the curvature. Radius of curvature for the circle is, say if it is rho, then this is 1 upon k, means ds by d psi. This you have to remember. This is curvature and this is radius of curvature, reciprocal of this. Now let me take a curvature for Cartesian coordinates. What is the curvature? Radius of curvature for the curve y equal fx is rho, given by rho, because we have taken rho as the radius of curvature. It is 1 plus y1 square raised power 3 by 2 divided by y2. Now how to find it? See, again, let me suppose that this is the curve and this is the point pxy. Obviously we are taking Cartesian coordinates, so this is the point. Let this be the tangent to the curve at P. Then this angle is psi, and we know from 12th tan psi is dy by dx. So psi is tan inverse dy by dx is y1, you know, tan inverse y1. Now psi is tan inverse y1, and y is, what is y? Y is function of x, so y1 will be function of x. So let me differentiate with respect to x. I will get d psi by dx. Now tan inverse, it is 1 upon 1 plus y1 square, and derivative of y1 is y2. So this is y2 upon 1 plus y1 square. Now this is d psi by dx. I will write it as d psi by ds and ds by dx. Chain rule. It is y2 upon 1 plus y1 square. Now I have seen that your d psi or ds by d psi, this we have seen, ds by d psi is rho. This is d psi by ds, so this is 1 by rho. ds by dx is equal to y2 1 plus y1 square. Therefore rho is 1 plus y1 square upon y2 upon y2 and ds by dx. Okay, this is rho over here. and this is over here 1 plus y1 square upon y2, and this is same ds by dx. Now what is ds by dx? This is 1 plus y1 square upon y2, and ds by dx is under root of 1 plus y1 square. How? Let me show this to you. Say this is the point pxy. Then this is x, and let me suppose that this is q, x plus delta x, y plus delta y. Then this is delta x, because this is x plus delta x. This is x, this is y, this is y, and this will be delta y. This will be delta x, because this is delta x, this is delta x. This is the point pxy. This is x, this is y. So this will be y. This is x plus delta x. This is x plus delta x. Now this will be delta s, as has been done in over here. This is delta s. Since this is the neighborhood of this point P, this will act as a straight line. By Pythagoras theorem, we have delta s square equal under root of delta x square plus delta y square. So this is delta s square, delta s only, or this is delta s square is without a root, delta x square plus delta y square. So delta s will be under root of this. So delta s by delta x will be 1 plus delta y by delta x square. So taking limits as delta x approaches 0, if you have to find it at p, you will get ds by dx is under root of 1 plus y1 square. That is it. So your rho is 1 plus y1 square whole raised power 3 by 2 divided by y2. Fine. Let me explain this again if you are not able to understand. This is like this. This is point P, xy. This is point Q, x plus delta x, y plus delta y. This is neighborhood of this point. At this point, this will be x, and this is y. You know, this is x-axis, this is y-axis. At this point, since this is x plus delta x, so this will be delta x. So that sum will be x plus delta x. If this is parallel to this, then this is also delta x. This is y, this is y. So this is the increment, this will be delta y. So that sum will be y plus delta y. This sum is x plus delta x, this is y plus delta y. So from this triangle, I have taken this triangle. This is obviously a curve, but behaves as a straight line because this is the neighborhood. So this is delta y, this is delta x, and this is delta s. So I will be having delta s square equal delta x square plus delta y square. So delta s will be under root of delta x square plus delta y square, which will be delta x square 1 plus delta y square by delta x square. So this is delta s by delta x 1 plus del y by del x whole square, and limiting condition dx by ds by dx is 1 plus y1 square gy by dx whole square. So that is it. I have used it here. So I will be having a rho. Radius of curvature for cartesian coordinates is 1 plus y1 square is for 3 by 2 divided by y2. Again, let me take up curvature or radius of curvature. Radius of curvature for the curve r equal to f theta, polar coordinates, r equal function of f theta. So radius of curvature rho is r square plus r1 square raised power 3 by 2 divided by r square plus twice r1 square minus rr2. R is function of theta, r1 is dr by d theta, r2 is second derivative, rr2 will be their product. Okay, proof is very simple. This is pr theta. Okay, this will be pole. This is phi. This is theta. This we have done in tangent normals also. And this is psi. This is the tangent, and this tangent makes psi, angle psi with the initial axis. This is angle between a radius vector and the tangent. This is theta, angle between radius vector and initial axis. You know, psi is theta plus phi. Simple. Psi is theta plus phi. So what will be d psi by d theta? It will be 1 plus d phi by d theta. This is 1. This is psi, exterior angle, sum of interior opposite angles, theta plus phi. So I have differentiated with respect to theta. D psi by d theta is 1 plus d phi by d. I need to find this d phi by d theta. Now we know rather, tan phi is r d theta by dr. Everybody knows it by now. So tan phi is r by dr by d theta, or r by r1. So phi is tan inverse r by r1. Now phi is function of r, which is function of theta. So phi is function of theta. So I can differentiate phi with respect to theta. D phi by d theta. Tan inverse 1 upon 1 plus r by r1 square d by d theta of r by r1. So this is r1 square, r square plus r1 square. Now differentiation is r1 square, r1 as it is, derivative of r1 is again r1. R is r1 minus r as is, derivative of r1 is r2. U by v form. Simple. R1 square cancels out. So this is r1 square minus rr2, r square plus r1 square. Now I have d phi by d theta. Let me use it in. This is 2. Using 2 in 1, I will have d psi by d theta is 1 plus r1 square minus rr2, r square plus r1 square. This is r square plus r1 square plus r1 square minus rr2 divided by r square plus r1 square. So I have d psi by d theta, r square plus twice r1 square minus rr2 divided by r square plus r1 square. This is further equal to, you see, this is d psi by d theta. In order to find rho, I need to have d psi by ds. So let me use chain rule. D psi by ds, ds by d theta is r square plus twice r1 square minus rr2, r square plus r1 square. This step I have done for this Cartesian coordinates also. Now d psi by ds is 1 by rho again. ds by d theta is r square plus twice r1 square minus rr2, r square plus r1 square. So rho is equal to, I will take rho over here. This is r square plus r1 square, r square plus twice r1 square minus rr2 ds by d theta. Obviously, ds by dx was under root of 1 plus y1 square. ds by d theta will be under root of r square plus r1 square. R square, r1 square. This is r square plus r1 square, r square plus twice r1 square minus rr2. So your rho is r square plus r1 square is power 3 by 2, r square plus twice r1 square minus rr2. This is the radius of curvature for polar. In order to know this, you need to See the book, or for to remember it, I will write tan phi is r d theta by dr. So tan phi, perpendicular base, and this is ds. You can, if you use ds square or ds under root of r square d theta square dr square, from this you will get ds by d theta is equal to r square plus r1 square. Okay, now let me take up some questions. Say you have uh, y square equal 4ax. This is the curve. This is in terms of cartesian coordinates. What I have to need, what I need is a row, radius of curvature. This is 1 plus y1 square raised power 3 by 2 divided by y2. So I need to find y1 and y2. Now let me differentiate with respect to x. 2y y1 is equal to 4a. So y1 is equal to 4a by 2y. So it is 2a by y. Again, differentiate with respect to x. y2 is 2a. This is y raised power minus 1. So minus 1 by y square. Derivative of y is y1. Simple. So y2 is minus 2a y1 upon y square. But what is your y square? Y square from 1 is 4ax. So this is minus 2 or y1 upon 2x. So you have y1, you have y2, they are radius of curvature. Rho is 1 plus y1 square raised power 3 by 2 divided by y2. It is 1 plus y1 square. What is y1? 2a by y. 2a by y1 square is 4a square by y square, whole raised power 3 by 2 divided by y2 minus y1 upon 2x. Since this is the radius, I will take it positive. This is y square plus 4a square y square raised power 3 by 2 2x by y 1. So this is the radius of curvature. If it is given, if the point is given, say your point is, say you have to find curvature. So question, let me take one more question, same question. Let me find radius of curvature for curve y square equal to 4ax at 2 3, means x is 2, y is 3. So you will get a definite value. Do it, you will do it of your own. Now let me take one more question. Say your x is a cos theta, y is a sin theta. This is not that theta angle between. This is say x is a cos t, y is a sin t. Now this is 1, this is 2. In order to find y1, this is x and y, I have to find y1 and y2. Let me differentiate with respect to theta. Dx by d theta is minus a sin theta. Dy by d theta, it is a cos theta. Therefore, dy by dx is dy by d theta by dx. It is a cos theta minus a sin theta. It is minus cot theta. This is y1. y1 is minus cot theta. Now differentiate with respect to x, because I have to find y2. Such type of questions you have already done in 12th. So y2 minus cot is minus minus plus cosecant square and d theta by dx. So 1 by sine square theta, d theta by dx is minus a sine theta. So this is minus 1 upon a sine cube theta. So you have y1, you have y2, you can find rho. Therefore rho is 1 plus y1 square. What is y square? 1 plus cot square theta raised power 3 by 2 divided by y2 minus 1 upon a sine cube theta. Now what is 1 plus cot square? Cosec square minus cot square is 1. So it is cosecant square. Theta raised power 3 by 2 into a sine cube theta. I have deleted minus sign because this is a radius. Now square and 1 by 2. So it is cosec cube theta into a sine cube theta. So this is A. Radius of curvatures. Cosec square is power 3 by 2 is cosec cube, and you have this one. Okay, this is A. So radius of curvature is constant over here. So you can take up so many questions are there. You can have. I will be sending few more questions to you. Okay.